Hi, I'm Lauren Saponaro, and this is my Physics 2211 Lab 5. So for this lab, I chose to analyze the falling motion of a slinky. And to do this, I compared the predicted and observed motion of the stretched slinky as it was falling from rest. And I used a video from the internet and compared the experimental data from that using Tracker. And then I created computational data in GlowScript and used that. And in both models, I considered the forces of drag and gravity acting on the slinky. And overall, I answered the question of whether the bottom of the slinky remains stationary. So the fundamental principles that this lab is largely dependent on is Newton's second law, gravitational force, drag force, the velocity update formula, and the position update formula. So here's a screenshot of Tracker. Like I said, I used a video provided. And so the initial mass was 0.25 kilograms. And then from Tracker, I found that the initial position of the slinky was 292 in that for the x component, negative 195 for the y component, and then 0 for the z component. And then initial velocity was just 0. And the change in time was 9.4 seconds. So here is a screenshot of my GlowScript code. I inputted the mass of the ball. Like I said, it was 0.25 kilograms. I inputted the position of the ball, the velocity vector of the ball, time as 0, and then the gravitational constant of 9.8, and the drag force constant of 2.6. And then here's just some more of the code. I had 2 while loops, calculated the net force. Here's where I used the velocity update and the position update formulas. So here are screenshots from the video that my computational model produced. And basically it shows the horizontal line for the slinky and then until about 6.4 seconds. And then that's where you see the drop. And it's when the slinky continues to fall until it hits the ground. So basically the results showed that the bottom of the slinky remained motionless until the top of the slinky collided with it. And the observers' predicted data is pretty much the same except for the initial positions. You can see that like the motion of the line is pretty much the same, and this could just be a result of the coordinate plane in Tracker. So to answer the question of does the bottom remain stationary, yes, it does, because the tension force is equal and opposite to the gravitational force, which keeps it motionless. And so the top and the bottom of the slinky are initially 2 separate systems, and then when the slinky's falling and the top of the slinky collides with the bottom of the slinky, the 2 systems become one. And that is what causes the bottom to begin moving with the velocity of the top of the slinky.